Right now, as you watch this, a car-sized robot is rolling across the surface of another planet, millions of kilometers away from Earth. Imagine that for a moment, a machine built by human hands, exploring a world that, for centuries, we could only gaze at through telescopes and dream about visiting. It's NASA's Curiosity rover, and today, August 6, 2025, marks its 13th year on Mars. 13 years ago, Curiosity made a daring landing on the Red Planet using a never-before-tried sky crane maneuver that had the world holding its breath. Since then, it's been a symbol of perseverance and discovery. That's longer than many pets live, and this machine has been working tirelessly, hundreds of millions of kilometers away from home, with no breaks, no vacations, and no repairs from human hands. Every day it faces harsh Martian conditions, freezing nights, dust storms, and rugged terrain, yet it keeps going. This isn't science fiction. It's the reality of human ingenuity and our relentless drive to explore the unknown. Curiosity is proof that when we dream big and work together, we can achieve what once seemed impossible. While we lived our lives here on Earth, celebrating birthdays, building families, and facing our own challenges, Curiosity embarked on one of the greatest adventures in the history of exploration, quietly making history on a distant world. It's driven over dusty plains that stretch for miles, navigating obstacles and sending back data that has changed our understanding of Mars forever. It's climbed Mount Sharp, a mountain taller than any in the eastern United States, slowly ascending layer by layer to study the planet's ancient history, one rock at a time. And it's drilled into alien rocks, searching for signs of past water and the building blocks of life, helping us answer the age-old question: could Mars have once supported life? It sent back hundreds of thousands of breathtaking images, giving us a front-row seat to the Martian landscape. Craters, dunes, and sunsets that no human has ever seen in person. This anniversary is a testament to the brilliant engineers and scientists who designed, built, and continue to operate this marvel of technology. Their dedication and creativity have kept Curiosity rolling long after its original mission was supposed to end. For 13 years, Curiosity has been our detective on Mars, sniffing out clues in the Martian soil and air, analyzing samples, and sending back discoveries that have rewritten textbooks. The rover has outlived its original 2-year mission many times over, becoming a seasoned veteran of the Martian surface, adapting to new challenges and continuing to surprise us with its resilience. And as we'll see, it's only getting smarter with new software updates and scientific tools. The adventure is far from over. Curiosity's journey continues, inspiring us all to keep reaching for the stars. Let's rewind to August 6, 2012, a date that would become legendary in the story of space exploration. On this day, humanity's eyes turned toward the Red Planet, waiting for a moment that would test the limits of our technology and our courage. The world held its breath as NASA attempted to land a 1-ton rover on Mars. In mission control, tension was so thick you could almost feel it through the screens, while millions around the globe watched live, united by hope and anticipation. The landing sequence, those infamous 7 minutes of terror, had to happen automatically, with no room for error. Signals from Mars take 14 minutes to reach Earth, so by the time we heard anything, Curiosity's fate was already sealed. Using a heat shield to survive the fiery entry, a supersonic parachute to slow down, and a rocket-powered sky crane for the final descent, Curiosity touched down inside Gale Crater. Each step was a technological ballet, choreographed to perfection. This crater, with its towering central peak called Mount Sharp, is a time capsule of Martian history, preserving billions of years of the planet's secrets in its layers. Curiosity's mission was ambitious: to find out if Mars ever had the right conditions for life. Its suite of scientific instruments was designed to search for the building blocks of life and clues about ancient environments. By climbing Mount Sharp, the rover could read Mars's history layer by layer, like a geologist studying the pages of a planetary diary, revealing how the environment changed over time. Within its first year, Curiosity drilled into a Martian rock and discovered key chemical ingredients for life: carbon, hydrogen, oxygen, phosphorus, and sulfur, elements essential for biology as we know it. It also found clay minerals formed in drinkable water, evidence that liquid water once lingered here long enough to alter the rocks, creating a potentially habitable environment. This proved Gale Crater was once a vast lakebed, an ancient oasis on a now barren world, and a place where life could have taken hold if it ever existed on Mars. No aliens were found, but Curiosity revealed a landscape that was once friendly to life, forever changing our understanding of the Red Planet's potential. That discovery changed our view of Mars forever, inspiring new missions and fueling our dreams of one day finding life beyond Earth. How do you keep a robot alive for 13 years on Mars? It's a question that pushes the boundaries of engineering, science, and human ingenuity. Mars is a world of extremes: freezing nights, swirling dust storms, and a sun that's often hidden behind clouds of red dust. For a robot to survive, it needs more than just wheels and cameras. It needs a reliable heartbeat. Solar panels weren't enough, so Curiosity got a nuclear battery, the MMRTG, or Multi-Mission Radioisotope Thermoelectric Generator. This power source is the unsung hero behind Curiosity's longevity, quietly working day after day. Inside, plutonium-238 decays, generating a steady flow of heat. Special thermocouples then convert that heat into electricity, providing a constant, dependable energy supply. It's a marvel of science, turning the slow decay of atoms into the spark of exploration. This steady power keeps Curiosity running day and night, through blinding dust storms and the bitter cold of Martian winters. When the sun disappears for weeks, Curiosity keeps moving, undeterred by the darkness. The MMRTG also acts as a lifeline, keeping the rover's electronics warm in the harsh Martian cold. Without it, vital systems would freeze, and the mission would end in silence. But over time, the battery's output drops, like an aging phone that doesn't hold a charge as well as it used to. Each year, Curiosity has a little less power to work with, making every decision more critical. The team must now budget every watt, every wheel turn, every laser shot, every experiment is carefully planned. There's no room for waste, and every action must count toward new discoveries. The challenge is clear: do more with less as the science only gets more interesting. The stakes are higher and the rewards even greater as Curiosity explores new frontiers. You can't send a mechanic to Mars, so the solution isn't new hardware, it's new software. The team on Earth must get creative, finding ways to make Curiosity smarter and more efficient from millions of miles away. It was time to teach this old rover some amazing new tricks, giving it the ability to do more with the power it has left, and to keep exploring longer than anyone thought possible. The answer? A brain transplant. Not a physical one, but a digital upgrade, a new set of instructions, a smarter way to think and act on the red planet. Curiosity was about to get a major upgrade, proving that with ingenuity and determination, even an aging explorer can find new life on Mars. Imagine using a 13-year-old computer, slow, outdated, and inefficient. That was Curiosity, until the mission team realized it needed a software upgrade. We can't touch the rover, but we can send it new code across millions of kilometers. A single bug could cripple the mission, so engineers tested the upgrade for years on Earth. Why upgrade? Efficiency. With less power each Martian day, the rover had to squeeze more activity into every sol. The new software would let Curiosity multitask, cover more ground, and analyze more targets. It would also allow the rover to make more of its own decisions, reducing the need for constant instructions from Earth. This autonomy is crucial, given the long communication delays. The upgrade would unlock Curiosity's full potential and extend its mission. It was time to unleash Curiosity's new superpowers. One of Curiosity's new superpowers is multitasking. Before, the rover did one thing at a time: drive, then stop for science. Now, it can perform science activities while on the move. For example, its radiation assessment detector can collect data while driving, not just when parked. Weather sensors can now run in the background, even while the main computer sleeps. This means more continuous data and a better understanding of Martian weather. By combining driving with science, Curiosity covers more ground and gathers more data. This efficiency saves precious hours and lets the team explore more of Mount Sharp. The upgrade is a game changer. Curiosity isn't just learning new tricks, it's transforming how it explores. The old rover is now a more productive Martian explorer. Every sol counts, and now, so does every minute. The mission's productivity has never been higher. Curiosity's other new superpower? Smart napping. The main computer used to stay on for long stretches, burning power even when idle. Now, when an instrument is analyzing a sample, the main computer can sleep, saving energy. It wakes only when needed, like a smart nap. The watts saved can be used for driving, science, or sending data home. This strategy extends the rover's life and boosts scientific return. Curiosity now has a more efficient daily schedule: work, nap, repeat. Smart napping helps the aging rover cope with its dwindling power supply. Every watt saved means more Mars to explore. With its new abilities, Curiosity is still making discoveries high on Mount Sharp. It's exploring strange rock formations called boxwork, delicate, web-like patterns left by ancient groundwater. These structures reveal that water once flowed through cracks, depositing minerals. The chemistry of these formations helps scientists understand the properties of ancient Martian water. Curiosity has also found rocks rich in sulfur, hinting at cycles of wet and dry periods. These clues suggest Mars's climate was dynamic, not just wet once. Each new rock and formation adds to our picture of ancient Mars. The rover's discoveries show a world that was once more Earth-like, all thanks to a 13-year-old rover that keeps getting smarter. Curiosity's mission is about more than rocks. It's paving the way for future exploration. Its data helps us plan for human missions, mapping radiation and testing technology. The Sky Crane landing system was so successful, it was reused for Perseverance. Lessons from Curiosity's long journey shape every new Mars mission. By proving Gale Crater was once habitable, Curiosity focused the search for life. Perseverance builds on Curiosity's discoveries, searching for biosignatures and collecting samples. Curiosity's legacy is inspiring new generations and missions. It's turned Mars from a distant dot into a real, tangible world. Its tracks are the first steps on a path that may one day lead humans to Mars. 13 years on, Curiosity's story is one of human achievement and relentless curiosity. Every image and discovery belongs to all of us. It's a shared adventure. The rover continues to climb Mount Sharp, while Perseverance explores Jezero Crater. New missions are on the horizon, driven by our endless quest for knowledge. Curiosity reminds us that science connects us all, across cultures and generations. The adventure on Mars is far from over. Stay curious, ask questions, follow discoveries, and imagine standing on Mars. Support the scientists and engineers pushing boundaries. The universe is full of mysteries waiting to be solved. Curiosity has shown what's possible when we dare to explore. Let's keep reaching for the stars. The next great discovery is out there.